Hey, hello, welcome. We're in Algebra 1. Here we're talking about how to make the equation of a line when we've got some points. We've practiced this a little bit with slope-intercept form when we had the whole line here. Today we're just going to have some points, and you'll see I've done some work to try to dissuade you or discourage you from using slope-intercept form. All right, example 1 from a graph. So we've got some dots, and we need to write the equation. So first order of business is to start to think about the slope, which is why I wrote m equals here. Now, as you go from one point to the next, you'll see it's going up 1 square and to the right 3 squares. So the slope is in fact 1 over 3, or 1/3. Now, just grab your favorite point. I chose the one there that I circled. Its coordinates are 8, 5. And with that information, we've got the slope over on the left. We've got the point coordinates. We can go ahead and write the equation in point-slope form. So y minus 5 equals 1/3 times quantity x minus 8, meaning times x minus 8 in parentheses. That's it. Later on, you'll see on the homework, I'm going to ask you to go ahead and try to practice taking that and putting that back into slope-intercept form with the same algebraic tools, the same symbol tools, distributive property and stuff that we've practiced before. There's our first example. Next one. Again, I've got some dots. So first order of business is to worry about the slope. You'll see between each 2 points, it goes down 4 and right 3. So the slope is negative 4/3. Grab your favorite point. I chose this one at 8, negative 9. Doesn't really matter which one you choose. And so the equation is y plus 9 equals negative 4/3. And then in parentheses, x minus 8. Something I want to be clear about. That is the only correct point-slope form if you're using that point, the one that I circled. If you would choose a different point, your equation would have a different point-slope form. Funny story, when you move into slope-intercept form, if you do the thing where you distribute the negative 4/3 and make it y equals, it actually ends up being the same no matter which point you use. So it's kind of an awesome thing about, well, math, because math has 1,000 awesome things. All right, so next example. This time we've got a table, and I'm asking you to, first of all, plot the point. So dot, dot, dot. There you go. Funny story, I had a cat named Dot Dot once. Okay, anyway, so you've got your 4 points. That last point, 4 and negative 11, that doesn't actually work. It's not on the grid, so yeah, whatever. So you got your points. Go ahead and looking for slopes here. It goes down 5, right 3, in between each pair of points. So the slope is negative 5/3. Okay. Grab your favorite point. And this time I'm going to circle it in the table instead of the actual point, just because it's easier. The numbers are already right there. If you would prefer to circle the point on the grid and then notice the coordinates, that's fine. It's just easier to circle it in the table. So we've got the slope, and we've got the point. So y minus 4 equals negative 5/3, and then in parentheses, x plus 5. Boom. Now, the question at the bottom, and this is the key as we try to make this transition away from needing the graph to just using the table of values, how could you figure out the slope without plotting the points first? And if you look at the table, hopefully you'll see that what's going on is you can count the differences in the x's and the y's. So, for example, on the y's, it's always going down 5. And on the x's, it's always going up 3. And so, boom, chicka boom, you've got yourself the slope, negative 5/3. Something to keep in mind because, hey, example 4, no more graph, just the table. So, we need to figure out the slope, and preferably without taking all the time to put the dots on the grid. It can be done, but, it's a lot of work. So, going after the slope, you'll notice it goes up 4 each time on the y's. Or rather, it goes up 4 each time between the y values. And on the x side, it goes up once each time. Okay, goes up 4, goes up. Oh, 4/1. which is, really 4. Boom, that's a slope. It's even easier than looking at the picture. All right, so you got your slope. Grab a point. I circled 6, 21. Just, I don't know, because it was the one that looked prettiest. Whatever. Doesn't matter which one you choose. And then y minus 21 equals 4, x minus 6. Now, again, I really want to emphasize, this is not the only possible correct answer. You do have to have 4 as the slope, no matter which point you're using. But you could have made answers with any of them. And you'll see on the homework, if you look at the answers, on the practice, if you look at the answers, you will see that I've listed all the possibilities, or at least all the kind of obvious possibilities that normal people would choose. There's lots of possible options here. All right, last one for the notes today. Here we have write an equation of the line passes through the, not a table, just these 2 points. And, really, you're off to the same task. So the y's, it goes down 6, and the x's go up 3. Gosh, it might have been slightly better if I'd done that in different colors. But you notice the y goes down 6, and the x's go up 3. And so it's just negative 6 over 3. It's negative 2. I mean, that's it. So you got a slope. Grab a point. I chose the first one because, I don't know, it was first. You end up with y minus 6 equals negative 2 times quantity x minus 5. And again, here, you could have chosen the other point instead. You'd have a different equation. This is it, folks. Figure out the slope by noticing the pattern. You can notice the pattern on the graph. You can notice the pattern in a table. Or you can just take 2 points and pretend that it's kind of a table-ish thing and just notice the pattern and say, oh, I suppose it probably continues. And get a slope, grab a point slope form, boom, 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 done. This is it. Thank you for watching, and please let me know if you have any questions.